and I'll screen share now. Come on, let's fire it off. Right. Welcome everyone to today's product appreciation session. We're going to be having a look at the Figure 4 system from 3D Systems. So thanks for joining us today. If you could keep any questions till the end, but if you have got a question that you'd like to jot down, there's a chat section at the bottom of your Zoom window, so feel free to type a question in there and I can respond to those at the end in the Q&A session. If you could just double check your microphones are off, that would be really handy. Turn them on at the end of the presentation. And if you're having any difficulty with audio or video, hopefully Martin's recording this so we can fire it out as per request after the session. So if you don't, you should already know a fair bit about ETG. So originally established selling Chiron machines, we offer turnkey solutions across UK and Ireland, and with taking HK on mid last year, ETG is now able to offer solutions for wire EDM, additive manufacturing and subcon laser marking services. We've got a very well-established team now. It's been growing a lot recently, and we're able to supply solutions as well as servicing for everything we can supply. So what we'll cover today is a brief sort of look over what 3D printing is, and this is going to be really just sort of snapshots, just to give you an idea of what is capable, what's out there, so you've got a better understanding of what myself and my colleague Russell Lane will be explaining in the near future as well. We'll take a closer look at the Figure 4 technology, or digital light processing as it's also known, the materials that are available on that system, applications that the system's cut out for, systems available to the market, and we'll do some Q&A at the end. So 3D printing, also known as additive manufacturing, exactly the same thing, just two ways of saying it. So instead of machining or grinding, fabricating, eroding a part from a stock material, you're producing your part from the bottom up. You're adding material to it. So instead of having a stock material that you're carving an item out of, your stock is stored as a spool of filament, a vat of resin, or a container of powder. All additive manufacturing technologies use a software to break the 3D model down into desired layers and creates a program. So very similar to what a post-processing system would do for a CNC machine. The software behind a 3D printer basically identifies what needs to be done on each layer to create the final part. There are many benefits of 3D printing over subtractive machining, subtractive manufacturing. So some of these include reducing waste materials, the lack of need for tooling, and it allows designers far more freedom to more easily achieve their properties required in their designs. So we'll take a closer look at some of the more common 3D printing methods out there. And arguably the most common one that people think about when you talk about 3D printing is 3D printing Yoda heads using FFF, or fused filament fabrication. It's also known as FDM, just another way of describing it effectively. Essentially, it's extruding a filament through a heated nozzle to create a layer before lowering the build bed to create the next layer on top of that. Really simple terms, it's a hot glue gun on a 3-axis. The software that's supplied with these machines effectively is a post-processor for each layer, so it will define, you can see the sort of skeletal image I've got below the GIF of the software creating the tool paths required to build a part. So this technology is really simple, and it's typically it's referred to as the most accessible, just due to its user-friendly and simplistic nature. Our principal for this technology under HK is Mark Forged. We've spent years perfecting this process and creating a way to also reinforce parts with a continuous fiber. So that creates some incredible strength. I'll not go too much into this because myself or Russell Lane will be going over this technology in a bit further detail in the near future. Another common one is SLS, or selective laser sintering. Effectively, by using a very, very accurate roller system, you can create a fine layer of powder. And by using a laser suspended above the powder, you can melt and bond the powder together to create each layer. It also bonds it to the layer prior to the one that it's curing at that time. SLS must fill the build space with this powder, so the system requires users to be very, very economical to ensure the build area is as full as possible. Unsintered powder can be recycled back into a future batch, but only at a ratio of about 2 to 3 with new powder. So SLS systems are typically a big investment, not only financially, but also regarding the post-processing and powder management systems that are required along with the printer itself. But the printers themselves can produce very, very high detail and great finishes on parts. SLA, or stereolithography, is the founding 3D printing technology. Back in 1983, Chuck Hull produced the first 3D printed part using SLA. Chuck Hull is the founder of 3D Systems. He's still there to this day, still an active part of the team. So it just sort of goes to show you that 3D printing is, although it's all over the headlines currently, it's actually been around for a long, long time. But we've still got a lot of education. We've got to get out there and get people thinking about it. So SLA stands for stereolithography. It's a resin-based printing system, and it uses lasers or lights to cure a photopolymer from a resin or liquids into a solid. They can create a very high level of detail across a wide range of materials. The systems come in a range of sizes, from little units that can sit on your desktop knocking out miniature Yoda heads, all the way up to 2-meter machines which can print the dashboard of a car in one piece. So a very, very wide aspect of technology there. That was 3 of around about 15 plus different technologies that are available. It comes in many flavors, 3D printing, and this is a great little graphic from 3D Hubs, and it showcases all the different types of 3D printing processes out there. This is likely out of date now because there just seems to be new technologies coming out every week. You'll notice there's about 15 processes in the middle there. I've highlighted the red ones where we have the technologies that we have access to at HK with 3D Systems and Mark Forged. And what we're going to be focusing on today is DLP. So what is Figure 4 or digital light processing? So that image there is what Chuck Hull originally attached with the patent for Figure 4. This was applied for years and years ago, and it's only recently that the products come out. They've spent a long time refining and perfecting this technology. Effectively, as I mentioned, you cure a vat of resin with a projector from below the vat. So there's a screen within this little vat of resin, and that is where the layers are created. Your stage drops into the resin and lifts up with each layer. Layers can be as thin as 10 microns They can be as thick as 50 microns. It's all very dependent on the settings that you put into the program beforehand. Because you're curing a layer at a time, this is the fastest, or one of the fastest 3D printing methods on the market. It's SLA refers more to lasers, so you'd have to scan a laser back and forth across each layer, whereas DLP or Fig4 simply cures a layer in one go. It's producing a very, very fast printing method. As I mentioned, it's 10 micron layer heights, so very good resolution in your Z, but equally very good resolution in your X and Y. 390 pixels per inch are achieved with the projector below, which is equivalent to the latest smartphone screens. So just to give you an idea of the sort of accuracy that can be achieved with this printer. So I'm going to try my best to link out to a little video now. So I've paused my share. Hang on, let's open up a new share. That one. So this is just a quick video from 3D Systems, just explaining the Figure 4 technology. Now the video does include their big all singing, all dancing setup, but it's just a nice sort of a visual representation of what's achieved with Figure 4. So we'll just share back to the presentation. Share, and then go from this slide. So one of the key selling points of the Figure 4 system is the wide range of materials that is available for it. And this is constantly growing. So this is a quick view of, not all of, but the main materials that are available for Figure 4. Upon release, the Figure 4 had a range of rigid plastics and an elastomeric material, along with a wax material for casting, targeted at the jewelry industry. But more recently, they released a range of tougher and more durable plastics, and have focused on being UV stable, so looking at end-use components to go straight out into market. So a quick sort of talk through some of these materials. The Tough Grey 10 was one of the initial materials released. It's a very fast printing material, so you can print up to 100 millimeters per hour, which makes it ideal for the likes of design offices wanting to prove out concepts and run through several design iterations in a day. Flex Black 20 in the middle there is a very, very high impact resistant material. It's very durable, and it's sort of like production propylene feel. It's great for functional prototypes, enclosures, those sort of applications. Rubber Black 10 was an improvement on Elast Black 10. Elast Black 10 was one of the initial releases. It was very good, very soft, but didn't have any tear resistance. Rubber Black 10 has sort of cured that and has excellent tear resistance. So it's good for soft touch applications, the likes of grips, handles, bumpers, as well as sort of over molding or coupling applications. Another interesting one as well is the high temp 300 in the bottom left. Now this material has a heat deflection temperature of 300 degrees Celsius, which is really, really good in comparison to what's available on the market. Interestingly, their testing systems for the heat deflection temperature wouldn't take it any higher than 300. So potentially there could be applications where it's suited for higher temperatures. We just don't have that information with us at the minute. Equally as well, it doesn't require any post-processing. So once printed, it can simply be snapped away from its build plate, washed and used. You can also see there's a range of medical materials which are fully sterilizable, so ideally cut out for medical environment. So this is a key tool which is being used in the fight against COVID-19 as well currently. So the main industry that Figure 4 is being targeted at is anything injection molded. The production system that you saw in the video there is effectively a way of getting toolless production out of a 3D printer. It's capable of producing up to 1 million parts a year, and the quality and finish of the parts is equal to what can be achieved in an injection molding facility. If you put that into context, the cost of tooling some of those little plastic parts on the screen there, if you're trying to do something development, something along the lines of development, you can be saving thousands initially just with a single printer to be able to design and develop your parts. Plastic parts like that can be used in all sorts of industries. So the Figure 4 really does apply itself to all industries. So from design departments through to electrical components and connectors, medical, as we've discussed, automotive scene. So, you know, the software can also apply textures. So a nice little example they've got there is a vent with a snake skin or a leather texture to it. This is all done really, really easily in the software, and you can see the sort of definition that can be achieved there just with the printer. Aerospace as well. So for projects that aren't critical parts, we've got case studies with businesses using Figure 4 to create old switches and knobs for aerospace use. And then there's an example there of the 2-minute pen. So that build plate there stacked with, I think it's about 30 to 40 pens. Each pen prints out the equivalent of 2 minutes a piece, just to sort of highlight the speed of this printer. So the system's available. We have the Figure 4 standalone system, which is ideally suited for design environments or small batch production projects. The system, the figure we attach to this is 500 parts a month and no higher really. It's the basic setup is around about £25,000. It's very user friendly. It's so you have to fill material yourself and attach your own post-processing methods along with it. A step up from that would be the Figure 4 modular system. So for customers who may be looking to take a small step in towards production and finding success, they can easily expand this system by adding more printers on at a relatively low cost. Systems start from around about £60,000, and you can add up to 24 printers run off a single PC station. So this is a way to take baby steps into small plastic part production. And then at the end there, you have the Figure 4 production, which we saw in the video. So this is a fully automatic system with robot arms inside controlling the build plates going into the right build engines, then being picked from their build engines into a wash station, from the wash station into a curing station, and then finally onto an exit chute where parts will effectively be in a finished state, ready to break away from their supports like you would from an Aerofix model. So this is capable of massive number of parts, massive number of materials, and the materials are all self-replenishing. So you should never run out of material post mid-print. So just to look back over the figure 4, the key points to take away from this system are it's a wide range of setups for systems from small design offices all the way up to mass production facilities. So it's available for all. The wide range of materials, the more recent release of materials being the UV stable ones, makes it ideal for end use components, not just for design iterations. The high levels of accuracy and detail that can be achieved on the printer really do target, again, end use components. Small plastic injection molded parts that you would typically see and have in your hand day to day could be printed now. It's one of the fastest printing technologies on the market. So great for design officers to get their designs settled. Once they've finalized their designs, it's easy for them to then go into production. And again, sort of going over myself a bit, but toolless injection molding, it really is that simple. And that is all, folks. If you have any questions, I'll have a look through the chats now, and we can people can feel free to turn the mics on, stick their hand up, and yeah, if anyone has any questions, please fire away. So we've got a question from Mike Jerdin. Material costs compared to the figure 4 system when used in production comparison. So the material costs will be exactly the same. There might be a small increase, I'd imagine, for the smaller systems, just purely because of the batch size. The material for the standalone is sold in 1 kilogram bottles. It's sold in 2.5 kilogram bottles for production systems. So you may find that buying it for production, you save a bit of money just because of batch size. Any hands up? Any more questions?
Yeah.
Go on, Gareth.
One, Tom. So could you give us a company case study that you've sold a figure 4 into, and why, and what they're using it for?
Yeah. So probably one of the more interesting ones was I've sold a figure 4 into Olympus. Now they were using it in their engineering department where they service equipment. Initially, when I spoke to them, they said they wanted things for jigs and printer to produce jigs and tooling. The Mark Forge system seemed more suitable for that, for the rigidity of the prints that can be produced and the user-friendly nature of it. However, they were absolutely blown away by the quality of materials and the quality of the prints from the figure 4, and decided that they would rather have a figure 4 system in there, able to produce parts that would fit their products far more accurately. So that was probably one of the more interesting sales. Steve Brown, how long is it?
Tom,
oh, sorry, go on.
I've unmuted myself just to. I was just looking at these questions here. I think it would be good if Millie could Steve Brown could unmute his mic and Millie could ask that question. Please.
Yeah.
What's the question?
Just there. Just read out.
I'll say it now.
Yeah.
How long does it take to make the machines?
How long does it take to make the machines? So the machines themselves, we can install them. It can take an hour to set a machine up. So they really are that user friendly, and the machines are so simple because there's only one moving part in the machine. Unlike the CNC machines that are sold by ETG, the figure 4 is so simple. If anything goes wrong on it, quite simply, 3D systems don't waste the time trying to send someone out. They'll just replace it. So, and sending a replacement machine in, the customer is almost at a point where they could set it up themselves. So it's, yeah, very, very quick to get set up with a figure 4. Jamie has asked, what are the benefits of each of the 3D systems? So each each technology has its pros and cons. So the likes of the figure 4, like I say, very, very high detail, but it's got a really small build area. So if you're looking to do anything big, you could break it down maybe and print it in multiple parts, but you're just adding a lot of work. Equally, the likes of the Mark Forge and the FFF printers, you can reinforce with carbon fiber, Kevlar, high temp, high strength fiberglass. So there's a lot of strength can be gained from there, to the point where you're producing parts which are as strong as aluminium on a 3D printer. So they've all got their own pros and cons, and you could go on for hours talking about all the benefits they've got. Connor, all parts have to be printed with honeycomb center, or it can be printed solid. So the pretty much most of the technologies allow you a lot of freedom. So the beauty of 3D printing is, because you're adding material, you can be as complex and creative as you like. So 3D printing instinctively, just softwares just go, yeah, let's hollow this out, let's put a honeycomb structure in there. Equally, you may want to machine the part, you may want it to be overly strong or weigh a particular amount. So yeah, you can make it solid, you can honeycomb it. The likes of the Mark Forge, their infill structure is typically triangular, and this is just due to the easy paths that it makes. It's all straight lines, whereas honeycomb actually takes quite a long time and can add a lot of time to the process. Martin Doyle has a question.
Oh yeah. But can you hear me?
Yeah.
Okay. Actually, I just saw a question come in after me from Graham, which is along the same sort of lines.
Okay.
As far as value of the machine's concerned,
Yeah.
can you give us an idea of what the sort of entry level machine would cost, right up to what's the most expensive machine you supply?
Yeah. So the base model, the standalone, which is ideal for the likes of design offices or people who just want to get into to have the ability to print really, really high def 3D prints. The standalone comes at around £25,000 up and running. The modular system starts at £60,000, and that is one control PC, one print module, and a curing unit, I believe. You can add up to 24 print modules. Each additional print module, I think, costs around 18,000. So for each additional printer, it's actually pretty reasonable. The printers on the modular are also material self-replenishing. So again, you just put a big cartridge in the bottom and it'll just top the material up as it prints. So again, you should never run out of prints. The production system, the all singing, all dancing, the one that's hopefully going to compete with all the injection molding facilities in the UK when we sell one, they start at 650,000. And again, they can be customized based on number of print units, number of post-processing units. So you could quite easily range into a £2 million setup to, cater for your needs. But yeah, they're the sort of investments that we talk about for the three stages, if you like.
Thank you.
What's the best thing you've made on a machine? What's the best thing I've made on a machine?
Tom, sorry, mate. Let me
go
just
on.
stop you there. Why don't you, as you're going down the questions, let them unmute and ask it themselves? Just
okay.
Make it a bit more interesting to see who's lost their voice or not.
Oscar?
What's the best thing you've made on a machine?
What's the best thing I've made on a printer? So I was working with a really interesting company recently, and they're a 3D. They do 3D printing themselves, but they came to us because they wanted to use the Figure 4, and we were printing taser housings. So effectively, a full-blown taser in the printer, so that they could then go to their customer, and instead of, as you can imagine, the police don't get a lot of volunteers for training to use tasers. So this company had created a way of a VR system for a taser. So this taser we printed was going to be loaded up with sensors and effectively go into a game to play with the taser, which was yeah, pretty interesting. So yeah, good question. Thanks for that one, Oscar.
Thank you.
Which of the machines do we see in our showroom?
So in the showroom, that's a good question. We've got the full range of Mark Forged, not the full range, we've got the best of the range of the Mark Forged systems. So the Mark Forged systems come as the desktop, industrial, and the Metal X. So we've got the Mark II, which is the best of the desktop range, the X7, which is the best of the industrial range, and then the Metal X system. So that's the long bench, if you like, with the Mark Forged equipment on. In regards to the 3D systems equipment, I believe we've got the an MJP 2500, which is a technology we didn't actually go over in this session, but we certainly can do at a later date. The Figure 4, which we've talked about, and I believe John has been working hard to get a 3500 up and running, which is effectively a bigger version of the MJP 2500. So that's what we've got in the showroom currently.
Thank you.
Gary Dickinson.
Hello.
Hello.
So what is the accuracy, for example, on something 100 mil squared, and how repeatable is that accuracy?
So the Figure 4 is sold with a Six Sigma repeatability. So I've been working hard on a PNB recently, and unfortunately some parts went to this customer and they were slightly oversized. Now, oversized compared to the model isn't always a bad thing. It wasn't ideal, but everything was consistently 1% oversized, no matter what we did. So quite simply in the software, it was a case of adjusting the software, right, shrink it at a percent in the Z, and they came out spot on. So it's I'm not sure what the actual figures are, but the Figure 4 system was sold as a Six Sigma repeatable machine.
Busting. Cheers, Tom.
No, thank you. Good question. Anybody else? Oh, Betsy. What we got, Betsy?
Can you print a unicorn?
Can I print a unicorn? I can print the best unicorns you can imagine. You draw us a sketch and I'll get it printed.
Yeah.
And I'll bet my little girl will have one as well. Good question.
Thank you.
Thank you.
No worries. Is anybody else?
Yeah,
No?
I've got one.
Go on. He's back again.
Yeah, sorry. What is the reliability of the Figure 4? Because I know historically, going back 5 years ago, the 3D systems kit wasn't necessarily reliable.
Yeah.
But what's the Figure 4 like in terms of reliability?
So the Figure 4, as I mentioned, because it's got so few moving parts, it's bringing 3D systems reputation back up, if you like, because you're not wrong. 3D systems have had not the greatest track record of printers and downtime. So the Figure 4 is really out there to change that now. And as I mentioned, they don't send really people out to try and fix anything, because the systems are so plug and play ready. It's as simple as sending a new machine out. So as far as I'm aware, we haven't had any issues yet from the ones we've sold, or the customers have loved them so far. So the Figure 4 is on par with Mark Forged equipment for reliability. Anybody else got any more questions? Are we recording this, Martin?
Yeah. So what I'll do is I'll send this out to everyone once we're finished, if we're out of questions. But yeah, I'd like to thank you on behalf of the audience. You've done very well.
No, thank you all for tuning in.
Stab at it all. So hats off to you.
Well on time.
More with that. So yeah, you can all unmute and we'll give them a little.
Oh no! Oh shucks! No, don't do that.
Oh.
No, thank you all for tuning in.
I'd ask you to take a bow, Tom, but I'm not sure if you're wearing pants.
So you have just we're keeping a running tally here. So you finished off at 48 participants.
Mega.
So well done. All right. So
yeah, fantastic.
Tomorrow, for those that want to come along tomorrow, we've got Mr. Mannion, John Mannion, on the Nakamura WT range. So look forward to that one. Make sure you keep your trousers on for it.
Good luck, John.
Tom.
Okay. Thanks again. See you later.
Yeah,
guys, all the best.
Bye.
Bye.
Cheers. Well done, Tom.
See ya.
Yeah.